Number 9, farm. You got a bug population. All right, you got a 0 starting point. Beautiful. That's cool. So you know exactly what happens at the time 0, and it's exponential. So you find a function that models the bug population using the weekly percentage growth rate. Now clearly it's growing. You just don't know what percent. Sometimes it's given, sometimes it's not. So find a function. What is the weekly growth rate? Okay, well let's find the function. We know it's going to grow, so I've got to figure out how does this change from one to the other. So what I do is, all right, I'm going to go ahead and grab 126 and divide it by 120 because this is a population model, which is mostly exponential. So I see here that's 5%. That's a 5% growth. Now I'm going to take the 132.3 and I'm going to divide by 126. Yep, that's also 1.05. So it is not a 105% growth rate. What it is a 5% growth rate. Okay, so that is a 5%. And so the function would look like this. Y equals, our starting point is already given to us because we have time 0. Sometimes that's hard. It's kind of hard to figure out what that is to make your model work. But we've got a growth rate of 1.5%, so therefore we're going to add it to 1, and we're going to get that right there, okay? So with that model and with our weekly growth rate, we're going to plug 10 into that guy so that would definitely take us way past, so we're looking at a number sufficiently larger than that. We've got 1.05. We're going to raise it to the 10th, right? Yeah, 10. And it looks like we got 190. We're going to round down actually because that's not 0.5. So we're going to go 195 bugs. All right, and does that make sense? Yeah, that makes sense. 195, yep. It's not that much of a growth. All right, now if you're looking for 1,130,000, that's going to take a long time, like a long time. So, oh man, we might as well set our table. Wait, did we plug in our function? No. So we got to plug our new function in because we need to go to the table and we got to find out how far along that is. All right. So I'm not even going to graph the guy. I don't care. I want to start my table, and honestly, I think I'm going to start at 100, just because 10 brought me to 200. Man, I should maybe go even 500, but I'm going to go to this. Now I'm looking for, this is in the millions, so I'm looking for E6, okay? E to the 6th is in millions, so 1.33 E to the 6th, okay? Or times 10 to the 6th. All right, so let me start there, and I'm going to go up by 1. Not even close, all right? So what I could do is go to the table set, and I can go up by hundreds, all right? Okay, so going up by hundreds, you can see that, okay, so it's in between 100 and 200. 200 is too high, so why don't I start at 150? 150. Now, you see what I'm doing is I'm not using the graph to zoom in, I'm using the tables to zoom in. And now I'm going to go up by tens. Okay, so now we're in the 180. Okay, and again, we are looking for 1.33, so we're 180, in between 180 and 190. So let's go to 180, and now we're going to go up by a year. Okay, and that takes us to 185. Okay, so let's go 185. And now we're going to go up by tenths. Okay, there's exactly a million. I'm going to go a little bit higher to 1.33. Keep going, go, go, go. Right there. Okay, so 190, 190.9 weeks. All right, so 190.9 weeks, divide that by 52. And so, yeah, so 3 2/3 years before it'll reach a population of 1,330,000, okay? All right, so again, that's how you use a table. It's beautiful. I love it. I think it's super cool. We got a piece of machinery, number 10, 370. It's depreciating, as all machinery should, over time. It's going to depreciate at a fixed rate of 6% per year. All right. I think cars are at 15% normally. How much will the piece of machinery be worth in 8 years? All right. Well, let's get the function going here. So y equals its initial value. Okay. Let's see. That is going to drop by 6%. So that would be 1 minus 0.06. All right. And we can just leave it like that or call it 0.94. Okay. That'll work as well. And we want to raise this to the 8th power. So 370. 1 minus 0.06 raised to the 8th power. It's going to be worth $225,540.51. Now that is actually A. B says you want to sell it when it's worth $170,000. So how many years should you wait? Okay, well, let's go to y equals. We want to go to the table and we want to figure out when it equals 170. So we're in that drill mode here. Grab the model, 370. Now I'm just going to subtract that. That's 0.94 because after each time period it has 94% left of it. And we want to raise that to the x power. So now we go to set table. Let's go back to 1 and we're going to go up by 1. Okay, and we are looking for 170. Okay, so 170 is in between 12 and 13. So it's in between 12 and 13. So let's start at 12. Go back to table set. Start at 12. Now I'm going to go up by 0.1. Go back to the table. Shoot. Lost the number again. What is it? 170. Right there. So it keeps depreciating. We're looking at 12.5. It's in between 12.4 and 12.5. So, man, I'm going to get exact just because I'm in that mood, you know. 12.4, and I'm going to go up by hundreds now. I can't help it. Right there. 170. Right there. 12.56. 12.565. We'll take the average. 12.565. So, you want to sell it in 12.565 years. That's when you'll get that. Okay, so it's in between these two values. Okay, where are we at? 8-minute mark. Let's do one more. Oh, I put the answer on number 12. Well, there you go. Okay. We got 439 deer, and the population is increasing at an annual rate. 5 years. Okay, that's a piece of cake. Man, this is so easy. You got 439. You start off with that. All right, and it increases. Okay, so clearly that's not around here. Our deer population seems to be growing by 20% per year. This is going up, so it's 0.046. And we want to raise it to the 5th power. Okay, so this is no tables at all. This is a straight up 1.046 for the percent. You're going to raise it to the 5th power. And it looks like we got 550 deer. Approximately 550 deer at that time. Number 12, there's already an answer for. All right, and we'll do 13 in the next.